Welcome students. Now we are entering into our second video. So same the chapter 1 electric fields and the charges, we are just looking over it, we know very well. So in this we are going to do the second problem, so which is based on same Coulomb's law. So Coulomb's law we are doing, already we did one problem, one model. That model what we did, what we found out, you know very well. Here we found out as nothing but charges which is impact on the ball 1 to ball 2, that is ball A to ball B, where we find out the charge of the second magnitude of the ball. Okay, we did that, we did on our first problem in based Coulomb's law. Here the second problem, what we are going to do, same Coulomb's law, listen the concept, you know very well. So here what the question, you must understand it. The 2 point charges, that is 4C plus 4E, okay, and plus E are fixed A distance A apart, where should a third point charge Q be placed on the line joining the two charges so that it may be in equilibrium. So these are the things we have to underline while do the problems, because these are the very hint to do the numerical. Okay, fine. In which case the equilibrium will be stable and in which unstable. So they are asking very clear about this problem. So which will be stable and which will be unstable. So first we have to, where we have to locate the third point charge, that we have to know very well, right? First, before going to do this problem, first we have to know what's the concept. Coulomb's law we know very well. So given question, first we have to draw the diagram. First we have to draw the diagrams. From the then you can able to do the numerical exactly. Okay. First this problem, this is not like a previous problem. This problem is different concept. Okay. First we have to understand the question. The 2 point charges now, that is 4E and E. So first we have to draw a normal line, that is nothing but a electric field line. Okay, so in which the two charges are placed. One charge is 4E, another charge is E. The two charges are placed at the two end. Okay, so are fixed a distance A apart. So the total distance is here as A between the two charges 4E and E. So the two charges which is located at the two end, the distance will be is A. Okay. Then what they are telling about, where should a third point charge Q. So where should a third point charge Q should be placed? They are telling that very clearly. The two charges are given. So third charge is going to be placed at which point in between the 4E and E. But they really know one thing very clearly, on line joining the two charges so that it may be in equilibrium. So I am going to keep a center part. Why I am keeping a center part? That is contained as equilibrium. That charge is nothing but we are naming as Q, because they given the charge, another charges Q. So I am placing Q. The total distance is A. So we have to find out this unknown distance. This distance we are considering as X, unknown distance. The remaining distance is we are considering as balance is A minus X. So total distance A, this distance is X, so remaining distance will be A minus X. We are placing the two charges. This is 2 point charges. No, point charge means rest charge, static charge. So between the Q, 2E and E, this is the third charge which lies the same line at equilibrium condition. We are placing at center for our understanding purpose. Now we are going to do the formula by using Coulomb's law. Coulomb's law formula we know very well. 1 by 4 pi epsilon naught into the charge which is given us here 4E into Q. So we have to write 4E into Q by Coulomb's law is what? K, Q and Q2 by R square. So Q1, Q2 given. What is the charge here? Distance as X. R square by here you should write as X square. That is equal to right hand side charge you have to consider 1 by 4 pi epsilon naught into what the charge? Q into E. Here 4E into Q, here Q into E. So you get put as Q into E, distance square. So distance here as X, here distance as A minus X. So you should put here as A minus X the whole square. Okay, now what we have to do? We can easily numerically we can cancel this 2 constant and put this equation here. 4E into Q square by X square, that is equal to Q into E by A minus X the whole square. So what are things we can able to cancel here? E, Q, alone we can cancel. So cross multiply, what will get the answer of the cross multiplication? 4 into a minus x the whole square equal to x square. How I put this equation, understood? So cancelling these two equations, we are getting 4 into q square by x square. So q will cancel, e cancel, cross multiplying, that is equal to x square. As per mathematics, we can remove the square root, right? Then what will become? Root of 4 is 2. So 2 into a minus x equal to x. I am taking square root, that's all. So we have to find out this unknown distance of x from the charge, whether it is stable or unstable. From the equation we can able to know. First to multiply here, 2a minus 2x is equal to x. Okay, now we have to find out x. So how do you put here? 2a equal to, this 2x minus will come to this direction, this sign equal to will become as positive. So x plus 2x, then 2a is equal to what? 3x. Then we have to find out x. So x is equal to what? 2 by 3a. So x equal to 2 by 3a. This is the answer of unknown distance where we found out now. X equal to 2 by 3a. So from this whether we can say it is stable or unstable. So we can easily find out the equation. You can able to know that 2a equal to 3a, so x equal to 2 by 3a. So we get the mathematical value. So it is completely, it is stable one. So where we place the charge q at center of the line, it is perfectly stable. So it is nothing but stable equilibrium, which is not unstable equilibrium, because we get a mathematical value as 2 by 3. If it is come the value as 0 or negative, then it will be unstable equilibrium. So it attains here as a stable equilibrium. So this is the answer of this problem. So I think very easy problem. You can look at one more thing to understand this concept. Very easy problem. So we will see the remaining things in our next video. Thank you, students.